Welcome back. Today we're going to talk about how to find the surface area of a composite solid. First, I'm going to discuss how to do it and the difference between a composite solid versus just a regular solid as we know it. And then I'm going to go through two examples, this first one and this second one, of actually finding the surface area of the composite solids. So let's dive in. So, in general, to find the surface area of a composite solid, we need to find the areas of each surface on each solid that is visible, but not include any covered surfaces. So, for example, this composite figure right here is made up of this square-based pyramid and this rectangular prism. Now, if we were asked to calculate these separately, we would calculate for this one and then we'd calculate for this one, right? We'd calculate both of them separately and include every surface. However, when we're asked to compute the surface area for the composite solid, notice that this square here, right, this 6 by 6 square right here, actually, I'm going to show you guys what I mean. This one right here is covered, and so therefore it wouldn't be included in the rectangular prism or in the square-based pyramid either. And so those are two that we could actually exclude from our calculation because we're not finding the surface area of these two things separately and then adding them together. We're just finding the surface area for the composite shape. And so whenever composite shapes are put together, if that ends up covering certain surfaces that were on the original shapes, those surfaces should not be included in our calculation. One way to kind of think about this is, let's say we were taking this and we were going to paint it. Let's say I'm going to grab some blue paint, I'm going to paint this. Would I need to paint this? Well, no, I would not, because that's inside it. I would only need to paint the other faces. Whereas if I was painting both of these individually, then yes, I would have to paint this surface and I would have to paint that surface. But I don't have to when we put them together because those two will just, those two will just overlap on each other and be covered, right? So here's an example. It asks us to find the surface area of this composite shape. So first of all, let's take a look at the square-based pyramid here. For the square-based pyramid, normally we would find the surface area of the base, right, the square itself, and then also the surface area for all four of the triangles here, right? Now in this case, all I'm going to do is just find the surface area of the four triangles. So let's do that, surface area of four triangles. And in this case here, we know this is 6 feet, so this also has to be 6 feet. So therefore, the area of the four triangles would be base times height divided by 2, and then times 4, because there's 4 of them, right? Since it's a square-based pyramid, there's got to be 4 of those triangles. So therefore, it's going to be 4 times 6 divided by 2 times 4, which is 24 divided by 2 times 4, which is 12 times 4, which is 48. So therefore, the answer for that first part is 48 square feet. So it's 48 square feet for those triangles. Okay, now I'm going to do the base on the very bottom here. This is a 6 by 6, so surface area for the square base is going to be equal to 6 times 6, which is 36, so 36 square feet for that one. And then last but not least, I'm going to do the surface area for all 4 of these rectangles all around it. 1, 2, 3, and 4. And so this is 4 3 by 6 rectangles. So therefore, the surface area of the rectangles is going to be 4, because there's 4 rectangles, and then times 6 times 3, because each of these 4 rectangles is a 6 by 3. And then we're going to end up getting that 4 times 6 times 3 is 72 square feet. All right, and then to find the overall surface area of the composite shape, that's going to be equal to all of these combined. So 48 plus 36 plus 72. And if you want, you can grab your calculator to find out what that is, or you can also do it by hand, is fine as well. But either way, we should get 156 square feet. And there we go. All right, let's now try this next one here. So this next one looks like a cylinder with another cylinder cut out of it. And so in this particular situation, to find the surface area, there's a few different things we're going to have to find. We're first going to have to find the surface area of this whole part around, right? This whole rectangle if we were to unfold the first cylinder. So let's do that first. So surface area for around our cylinder, and I should say outer because there will be two of these, but let's start with the outer one. Well, here we have a height of 10 feet. And then here we have that the radius of the full one is 4 inches. And we know that the circumference is 2 pi r, right? And so therefore it's going to be 2 pi r h for this, right? For the surface area of all this all the way around and down there and for this rectangle. So that is going to be 2 pi r, right? Because that's our circumference of a larger circle times the height. So in that case, that is going to be 2 pi times 4 times 10, which is going to be, well, let's see, 4 times 10 is 40, and 40 times 2 is 80. So that'll be 80 pi. So therefore, so far we have 80 pi square inches. Now I'm also going to do the surface area for the smaller one, right? For the smaller cylinder, right? Because we would have to paint in here. So what is the surface area for the smaller cylinder's rectangle? Well, for the surface area for the smaller cylinder around, we would have 2 pi r h again, except this time r is referring to this r, right? The radius of 2 for the smaller cylinder. So that's going to be 2 times pi times 2 times 10, which is 40 pi this time. And then last but not least, I need to know this circle on top and this circle on the bottom, what these are. But keep in mind, we're not going to paint the full circle. We're going to paint that circle minus this one. And we're going to do that twice because for the top and for the bottom. So the surface area for bases in this case would be pi larger r squared minus pi smaller r squared, and then times 2, because we're doing this twice. We're doing it for the top and for the bottom. So that's going to be pi 16 pi here, because 4 squared is 16. 2 squared is 4, so minus 4 pi, and then times 2. That's going to be equal to 12 pi times 2, which is 24 pi square inches. So then to find the overall surface area, we're going to add all those up. So we had 80 pi plus 40 pi plus 24 pi. And so overall, that is going to be 144 pi square inches. And there we go. So this was a big topic. Feel free to please leave any comments you might have in the questions you have in the comment section. And we'll see you for the next one.